Back in the late summer of 1977, NASA set into motion one of humanity's most daring adventures by launching two robotic explorers named Voyager 1 and Voyager 2. These twin spacecraft weren't just machines. They were bold pioneers sent to journey beyond the familiar planets we grew up knowing, venturing deep into the vast, uncharted expanse of space. Each Voyager was packed with scientific instruments, carefully designed tools intended to reveal secrets of the cosmos that had never been touched before. More than just cameras and sensors, they carried the dreams and curiosity of everyone on Earth, daring to push the boundaries of what had ever been accomplished in space exploration. Though the technology aboard the Voyagers might seem outdated, today barely rivaling the power of a modern smartphone at best, back then they were marvels of engineering, built to endure decades of relentless cosmic radiation, intense gravitational forces, and the cold, lonely vacuum of space. These spacecraft were designed to last far longer than anyone expected. Voyager 2, in particular, followed a precise, carefully plotted course, using gravity-assisted slingshot maneuvers around the giant gas planets to propel itself further and faster through the solar system. This journey became a grand tour, capturing stunning photos and gathering groundbreaking data about planets and moons that until then were just blurry specks in the night sky. Early on, Voyager 2 zipped past Jupiter, offering the world its first detailed views of the planet's great red spot, an enormous storm, centuries old and larger than Earth itself. The spacecraft revealed swirling turbulence patterns in Jupiter's thick atmosphere, its faint, delicate ring system, and even uncovered, previously unknown moons caught in Jupiter's powerful gravitational pull. But Jupiter was only the beginning. By 1981, Voyager 2 reached Saturn, whose elegant rings and swirling clouds amazed scientists. Building on data from Voyager 1's earlier visit, it showed that Saturn's rings were far from simple bands. They were complex, dynamic structures, filled with braided patterns, gravitational waves, and oddly shaped particles, painting a picture of a world alive with motion and mystery. Voyager 2's journey then took it to planets that had never been closely studied before. In 1986, it arrived at Uranus, a distant, icy giant wrapped in a ghostly blue haze. Unlike any other planet, Uranus spins on its side, tilted at a staggering 98 degrees from its orbit. The spacecraft sent back haunting images of this frozen world where temperatures plunged to a bone-chilling 353 A's, 230 degree W's. It discovered 2 new rings and 11 previously unknown moons, transforming our understanding of this faraway planet. Voyager 2 even passed through a rare magnetic bubble thrown off by Uranus's tilted magnetic field, providing precious new insights into how magnetic forces work on such strange, icy worlds. The Grand Tour didn't end there. In the summer of Jacta, 1989, Voyager 2 made history again by becoming the first, and so far only, spacecraft to visit Neptune. This distant blue world was revealed as a stunning jewel, with an atmosphere thick with methane and whipped by hurricane-force winds exceeding 200 miles per hour, the fastest in the entire solar system. Voyager 2 spotted Neptune's own storm, the Great Dark Spot, just as fierce as Jupiter's famous red spot, and captured images of its faint, elusive rings. But perhaps the most incredible discovery came from Neptune's largest moon, Triton, where Voyager 2 witnessed nitrogen geysers erupting from beneath an icy crust. The possibility that a hidden ocean might lie beneath Triton's surface sparked exciting questions about where life might exist beyond Earth. As Voyager 2 moved ever farther from the warmth of the sun and deeper into the cold emptiness of space, it never stopped listening or sending back data. In 2012, its twin, Voyager 1, crossed into interstellar space, the space between stars, breaking new ground as the first human-made object to do so. Voyager 2 followed 6 years later in 2018, becoming humanity's second emissary to this vast, unexplored realm. Even in this alien frontier, beyond the reach of the sun's protective bubble, Voyager 2's instruments recorded faint signals, the hum of interstellar plasma, giving scientists a first-ever measure of the space between stars. Though Voyager 2 is now more than 14 billion miles away, it still sends data back to Earth. Each message takes over 18 hours to travel at the speed of light across that staggering distance, arriving as faint whispers barely rising above the cosmic noise. What makes this even more remarkable is that Voyager 2 was originally designed for just a 5-year mission. Now, over 47 years later, it continues its silent voyage, powered by a small nuclear source slowly decaying over time. The mission team has had to make tough decisions, shutting down some systems to conserve energy. Yet the spacecraft still functions, consuming less power than a household light bulb. Its endurance is a testament to clever engineering and human ingenuity, stretching the limits of what's possible. The final images sent home by Voyager 2 are hauntingly beautiful. Dim stars, distant moons shimmering faintly, and the soft glow of a far-off galaxy it now calls home. These last gifts from a silent traveler show not just alien worlds, but offer us perspective on our own place in the universe. Fragile, small, yet capable of reaching out beyond ourselves. Attached to Voyager 2 is a golden record, a time capsule, bearing greetings in 55 languages, the sound of crashing ocean waves, a mother's heartbeat, and music from around the globe. It's a message in a bottle, cast into the cosmic sea, a declaration that humanity was here and dared to reach for the stars. Though it may never be found, Voyager 2 sails onward, quiet and eternal, a monument to human curiosity and spirit. Long after Earth itself may fade, this little spacecraft will drift between stars, carrying the soul of our civilization on that golden disk. Its legacy isn't just about science. It's about inspiring generations to look up, ask questions, and believe in the power of exploration. Voyager 2 changed how we see the universe, bringing us closer to alien worlds and reminding us how rare and precious our own planet truly is. As its last signals fade and its systems go quiet, its journey will live on. As a quiet traveler between the stars, echoing our story across time, reminding us all that we are part of something vast, mysterious, and infinitely worth exploring.